Okay, so making maps. This is what we're gonna work our way through, and so we have to talk about a variety of different things. This might be one of the longer talks that I give about things, just because I have a lot of different examples to go through. I want to show some other things. We're going to talk about different types of maps, what kinds of data they're displaying, some principles of good map design, which kind of hold for not just maps, but just making any kind of visual medium, a poster or something like that as well. We're going to talk about colors a little bit, because color plays an important role now in maps particularly, because we're going to try to if we're going to try to convey as much information, you usually do that through color in some way. And then some different suggestions and ways in which to display different kinds of features in ways that will be understandable to other people and will make your map as clear as possible. So to start with, this is called symbology, and you guys are aware of symbology because we've been having some trouble with that on these computers, and hopefully IT can get that straightened out by Friday. Otherwise we may have to come up with some other alternative. But the questions you will need to ask yourself as you're planning your project, and actually once you have your data in place and you're thinking about designing a map, is how should you display your data? In what form would best illustrate the whatever hypothesis you're trying to test? And so that could be by color, that could be by size. You could use different sized symbols, you could do different shaped symbols. You could classify it in different ways to show the difference between some areas versus other areas. So all of these are different potential parts of dealing with a map and thinking about those kinds of things. And a lot of it is going to come down to, first, what the purpose of the map is. Well, first what your data are, then what the purpose of the map is, and then finally what information in that you want to try to illustrate. So trying to emphasize some data over other data. All right. So to start with, we'll talk about qualitative maps. Just different ways in which we can show relative differences or things like that, and then we'll talk about how we can show different ways to quantify those things. So to start with, as you add data to ArcGIS, and you may not have really thought about it or noticed it, but as data comes into ArcGIS, it's displayed as a single symbol. And so all the features of the data you added will draw in the same way. They'll be given the same color and a single symbol. If it's a point data like this, it's usually just a round dot, and then ArcGIS will randomly assign a color. So you may have noticed, if you're looking at the person next to you, why is your dots blue and mine are pink? And that's because, what was that, like 2 minutes? Okay. Yes, I'm still using the system. Stop. That's ridiculous. Okay. How long do they think these classes are? Terrible. All right. So the ArcGIS will randomly assign a color. And why, for example, let's try to think yourselves, why would you use this method? Why would you use a single symbol for something? Why should you use a single symbol for something? Go ahead, Mike.
So basically, the one element you're trying to display is all the same, identified easily.
Mm-hmm. Yeah, exactly. So if there isn't really a difference between any of the individual things that you're showing, you're going to want to show it as a single symbol. Otherwise, it's confusing, and you will confuse people if you're varying that symbol in some way and you're not trying to show something. So single symbols can be very important. All these streets, in this particular case, you just want to show streets, right? If you wanted to differentiate which of these might have interstate numbers, which some of these do. Which of these are, sort of one-way streets versus two-way streets, or something? You could categorize them. But if your goal is to not emphasize, just show where there are streets in Washington, D.C., then that would work just fine. This also, typically, you want to use signal symbols for natural features. Right? This is, unless there's something specific you're trying to illustrate about the natural features, you want them in the background to just sort of be there. Right? Things like water should all be displayed the same way. So rivers would all be, or streams, all given the same kind of classification and shown the same way on your map. Now, we can display then, another choice that we can show things is based on a unique value. So, depending on our data, we can bring in data that has a spatial dimension so that we can put it on the map, and then it can have lots of associated data that gives you more information about everything that you're showing. So in this particular case, we have this map of New York City is divided up into different types of land use. So the data has a field for land use, and we can display separately each of these different categories of data. So unique values work well when we have different categorical data, something that we can classify in this way. And so in this case, these are polygon data, right? So they're representing areas. All the areas are given a different color based on what land use category they're assigned. You can relatively easily do that in ArcGIS, and really any GIS system. I mean, this is sort of basic stuff. You could change. You could adjust those colors. You could make groups. You could group them if you wanted to. So say you wanted commercial and manufacturing to be one color, everything else to be another color, to emphasize that. There's lots of decisions like this you can make in ways to bring out what it is you specifically want to show. And you can do this with single symbols, right? So in this case, we have two different changes being made to these point data. So these are point data in this case. They don't look necessarily just like points because they have a shape, but these are point data nonetheless. The shape size is relatively arbitrary. You want to set that to be something that's legible. Now, what are the two things that are changing about those symbols? The color and the shape. All right. It can be advantageous to do that. It can also needlessly complicate your map. All right. So depending, you need to make those kinds of decisions. Is it just as clear to just change the symbol, or is it just as clear to just change the color? There would be reasons to do both. You might not want to change both at the same time, but you can, right? Changing both at the same time really emphasizes the differences between that. But if you wanted to group, say, different areas or different other kinds of things, you could decide to do all the same kind of symbol, just different colors, or different symbols with the same color. So in each case, there's going to be advantages and disadvantages to that. I sort of mentioned that, but what's the big advantage to changing the two things about the color and the shape?
Just really stands out.
Yeah, it really stands out. So yeah, if you really want to make it clear, particularly if you have a lot of overlapping symbols, that can be helpful because you can start to pick them out. If they were all the same color, they would really blend together. Where they're especially at this scale. At this scale, those symbols might be a little too large because they're overlapping so much. So you can also adjust symbol size. Try to show things as clearly as possible. All right, so let's look at some quantitative maps. All right, quantitative maps are where we're incorporating not just categories, but some other kind of data that's associated with that. All right? So in this case, we're putting features into classes, and how we divide that up we'll talk about a little bit later. I didn't want to get too far into that, but we can divide them up into just different size classes. All right? And then the symbol size reflects the class values. And so why would we want to use this technique? What's the advantage to showing a graduated symbol like this? Yeah.
Densities or abundance.
Oh yeah. Okay. So different kinds of data. Yes, you could show densities or abundances, and they're in a sense kind of both changing. So showing two things: how big the houses are. We have two different kinds of data being changed here. So the darkness is we're getting more people in a household, and then the number of households is by symbol size. All right. Now, in this particular case, we're categorizing these by county. I think is that county? That may not be county. That may be some. What's that? Well, county or whatever. It doesn't really matter. In this case, you're showing a symbol for each of those areas. So, yeah, county is probably not right. That's Connecticut, so they're not going to have that. There may only be a couple counties in Connecticut. Anybody from Connecticut? How many counties are in Connecticut?
I have no idea.
More than 5?
I think probably 5, honestly.
Okay, so those
maybe 1.
So those are probably something else, either like townships or census tracts. They may be census tracts actually. Although if they were census tracts,
Like I live in Fairfield County. That's like all that on the left.
Okay.
There's like 100 houses in Fairfield.
yeah, but Connecticut is
Yeah.
a tiny town. There's not that
Dr.
many.
George, there are 8.
There's 8. Okay.
That's
8.
Yeah.
8 counties.
Those are probably just townships.
Yeah. So what?
Townships.
Townships. Yeah, that's what I'm thinking. Townships.
Those are towns.
So they probably correspond some to towns and just sort of surrounding areas around that. Doesn't really matter what they are. But in this case, we're using a single symbol to represent the total data that's within that township, let's say. And so this works very well at this scale because the dots all fit essentially within that. It's scaled nicely. It's fairly clear. It's pretty easy to pick out differences in density. You can see where there's larger households and also more households. And so out here we get actually pretty small average household numbers of households. The smaller the dot, the harder it's going to be to differentiate these colors. And these colors are potentially a little too close together. So we'll talk about that in just a minute. So what we have shown here is what is called a choropleth map. And you may have noticed that word in the chapter. How many people noticed that they talked about choropleth maps? All right. So this is going to be something we'll talk about the rest of the semester, basically. It's likely some of you will employ choropleth maps for your project, just because it's just a colored map. That's all it really means, is it's a colored map. In this particular case, it's showing the percent of uninsured people by county for the entirety of the continental U.S. And so these are from 2005. You can see some pretty significant differences across the country, right? There are the farther west you get and south, the higher the percent of the uninsured becomes. And in this case, the color scheme is using 2 different colors, which helps really show the difference. All right? Typically, for one variable, we'll get to that in a second, but typically this is a little unusual, but they're really trying to emphasize the difference between the lower values and the higher values, so you can really pick that out. Typically, when you have a single variable like percent uninsured that's relatively continuous, just increasing, you would use a single color and then change the saturation on it to indicate that. But there are reasons to make different kinds of decisions. That's one of the things that we should just start thinking about, is why we display things in other ways. We'll see a lot of U.S. maps like this. And one thing to always keep in mind is that, well, is what? What is different, particularly east to west, if we're looking at a county map of the U.S.? Size of the counties? Yeah, you get big counties out west, and you get tiny counties in the east. And so your eye is naturally drawn to these big areas. But in this case, it is percentage, which is useful. When you're showing a map like this, you almost always want to show it in terms of a percentage, because absolute numbers are also going to vary radically. There are counties out in the western U.S. that only have like tens of people, as opposed to counties in the east, which might have 1 million people in them. So there's going to be orders of magnitude difference in the size of the population or something like that. So percentage is very, scaling things to population size is really important if that's a variable you're looking at. All right, so let's take another look at another one. All right, so here's another form, another kind of choropleth map. In this case, vacant housing units, and this is a little bit more typical when you have a single variable. You're just going to go from light to dark to show increasing vacancies around the country. Some places very low numbers, other places fairly high numbers. Okay. You might also notice there's a slight difference in the shape between these maps too. Anybody pick that out? If we go this way, look at this, look at this, look at this, look at this. Why is that? Why is the U.S. slightly different shaped? Different projection. This is probably a Mercator projection, because if you look at the top line of the U.S. is a line of latitude. It's a specific latitude line. It's 48 degrees, I think. Anybody know?
That was like
That's more than that. Yeah, because 40 goes through Pennsylvania. So it's 38's like where we are. We're at like 38. And so that's probably Mercator projection. This is an equal area projection. And so there's a little bit more of a curve because it's going to be a conic projection. That tends to be a little bit better. There's not much of a difference if we're just looking at the U.S., but you'll see the U.S. does get stretched out a little bit more east to west, and can put a little bit more emphasis. Just makes the whole western U.S. look bigger to me, anyway. And this seems to balance it a little bit better. So if you're showing the whole of the continental U.S., an equal area projection I tend to prefer, especially on a colored map like this. All right, so let's look at some different ways of displaying the same kinds of data. So here we have Pittsburgh, city of Pittsburgh. You might wonder why there's like a lot of stuff in the city of Pittsburgh, and it's because the authors of that book that I've used they're at Carnegie Mellon University in Pittsburgh, so they've got a lot of data. So Pittsburgh gets used as an example a lot. Now here we have the population of people over the age of 65. So the numbers, these are just straight numbers of people that are over 65. And you can see differences, right? These are in census tracts. Census tracts. So these areas we can look at, all right? So the darker the color, the more people we have. We can normalize that to population, which tends to be what you always want to do if you're showing any kind of population data. You want to divide what you're showing by the total number of population to get a percentage. That way, because you're really interested in showing relatively how many people are there. Absolute numbers are okay, but there's always going to be more people. Well, there's generally going to be more people. If there's more people, there's going to be more of every different category you're going to look at. And so by normalizing, you can take that equation out, and you can say, not just are there a lot of old people, but where's there a high concentration of older people? All right. So you could in this case, some of those areas are up to 50% people over the age of 65, and you might not recognize that if we look back at, oops, wrong way. If we look back at just the total numbers of populations, some of those are still dark. There's a lot of other dark areas. Once you normalize, it starts to become clear that there's definite differences in parts of Pittsburgh where there's older communities. Okay? Another way to look at this is in terms of population density. So in this case, we're looking at population per area. So it's a different kind of normalization. But you can also see where there's differences in concentration. Right? The darker the numbers, the higher the concentration of older people are. So all of which, if we were asking some question about maybe where we would want to put particular services for people who are older, or if we were trying to market to people who are older, we might want to take into account all of these different ways of showing data. If we were just interested in numbers of old people, or older people, I shouldn't say old people, 65 is not that old, we might want to look at this. And then there are lots in some of these other parts, but if we're really just interested in finding the most concentration of older people, and that might have other things we might want to look at. We might need to think about healthcare or easy access to stores and things like that. All different kinds of reasons that we would want to look at that. All right, so those are some different maps, we're starting to get at some of these principles of good map design. So a few things to keep in mind. A good rule of thumb, it's not absolutely true, but a good rule of thumb is to minimize ink. Right? The less on your map, generally the better. If only just to make your map a little bit more readable. So the more white space that you can employ can emphasize specific things. Now a choropleth map by nature is going to have some color to it, and depending on what you're showing, it may be all in color. That's okay. But if you're trying to illustrate lots of different kinds of things, you need more white space. Basically, the more that you're going to put on your map, the more important white space can be. If it's just a choropleth map that shows the color of one thing, color that map in, make it look nice. But if you're trying to show a lot of different kinds of data, you're having different kinds of symbols, the less color, the better, because it'll make it easier to pick out particular symbols, right? So there's a little quote from a geographer that clutter is not an attribute of information. Clutter is a failure of design. So thinking about making your maps as clear as possible is actually pretty important. So a few things to think about. Light versus dark colors. So the darker a color is, the more important it's perceived to be by our eyes. Our eyes are going to be drawn to the contrast. So the darker a color, the more we're going to focus on that. And if we focus on that, that should be the most important thing that we're trying to show. Right? Let's look at a couple maps to illustrate this. If we look here, these are vacant units out of total units. So what percent vacant units are there? And in this case, what are we emphasizing on this map? Look at the values down here.
Percent of people in that area that do that?
Well, kind of. These are vacant apartments or vacant houses.
The percentage of vacant houses, apartments in the
Right.
area.
So we're emphasizing where there are a lot of empty places. Okay. But that may not be that may be what we're interested in, but it may not be. If we look at it this way, all right, what are we emphasizing now? Where there's less, the places that are mostly full of people. Okay, So which map would you want to use if you wanted to argue that we needed to build more houses in a particular place? Should we use this one? Or should we use this one? Why the other one?
Because it shows there's too many people.
The emphasis is on the fact that there's very few apartments and things are available here, so we need more housing in these areas. So this would be the better way to illustrate that, because we're being drawn towards the thing we want to emphasize. If, on the other hand, maybe we were trying to encourage people to move to areas where there was lots of things, giving people, I don't know, like some sort of financial, like tax break or something that would help encourage people to live in these areas where there are fewer people, we would use this map. All right? So making these kinds of decisions can be really important. Now, the greater difference between light and dark, so these are the values, the color values, or the if it's not color, it's just the contrast in dark or light, the more we're going to notice those things. All right? So usually this is one of the main reasons why we want to keep the background light, is that way we can pick out what we want to be important. Because the darker something looks, the more our eye is going to be drawn to it, and we want to emphasize that. All right? And you can kind of see that if you look at these ampersands here. Which one, if you look away and you look back, which one do you see first? The left one or the right one? Yeah, the left one. It draws the eye a lot clearer. And so if we're doing illustrating a map that's going to be analytical, we're going to try to show some other data. We want to make the background features sort of fade to the back. So these are outlines of there's a couple of things here. There's topographic lines, and there's blocks, and there's just the general outline around the rivers. But they're all very close in color to the background. They're not standing out in any particular way. All right? And so the more neutral the colors you select, or if you don't select something that's a color, like gray, the better. So grays and light browns, they just kind of fade to the background. We don't really notice them. All right? If you don't want to call attention to them, we can remove the outlines. All right? So take a look at this map. This has building outlines on it, but we don't want to emphasize the buildings necessarily. We might want to just show that where there are buildings, and so contrast that with that. All right? So look, you can really pick out those buildings. So if you're doing something with the buildings, you might want to have an outline, but often you don't. And I find in most cases, depending on what you're illustrating in the background, removing the outline is often the first step that I do if I'm making a particular map. It can help de-emphasize the sort of the space between them. And there are lots of tools in ArcGIS, if the symbology tab is working right, that lets you adjust how big the outline is, how dark the outline is. You should almost never, even if you are showing the outline, is use black, straight black for that. Use a very dark gray. That'll help blend it a little bit. So there are some cartography tricks and things that you're gonna learn and think about how to make your maps look as good as possible. All right, so let's look at this in a smaller scale map. We're going to look at this is another county level map of the U.S. All right, in this case, we're using the outlines to call attention to all of the different features. In this case, all the different counties. Right? Now, this helps you pick out where there are individual counties. And that could be important if you wanted to talk about specifics, essentially. You could do it that way. But if you make the outlines lighter, you now focus more on the color. So this way, we're focusing on the shapes themselves, the counties themselves. In this case, we're focusing more on the color values that we've put in here. And typically, this is probably what you want to move, unless you have a very specific reason of identifying all the counties. that way. In fact, you could even fade these out completely if you weren't interested so much in political boundaries as well. So we could have states on here, but we might not need to have states on here. We could have these county lines, we could make those all go away. And if we just wanted to talk about the pattern across the US, or if we were in a particular state, the pattern across a state. So boundaries should be a tool that you should decide whether or not you're going to use or not. All right? So this makes a very busy map. All right? If you look at this is Pittsburgh again. By coloring, giving even a beige color to the background, it really makes it look pretty messy. But if we take that out, it becomes a little easier to see things. I think it starts to fade a little bit better. It looks a little bit better. And then if you want to really emphasize buildings in this case, you can use a darker color to increase that contrast. The more contrast, the more obvious things are going to be. And lighter for less values. So this forms like a nice base map. ArcGIS has a lot of nice base maps built in, and so picking one though that's appropriate to what you're trying to say can be important. If you're working at they're good for small scale maps. They're showing a lot of area. The built-in background maps are good for that because they cover a lot of space. Although it just depends on the kind of map. But a lot of the maps that you guys are going to make, you probably will either build your own background like this, or you won't have a background to them. And you don't need to because you're trying to show other things. All right, so let's talk a little bit about color. This color becomes an important thing. The hue is the basic color. Red, blue, green, pink, any of those. Well, not pink. Red, blue, green, yellow, purple. However many colors we want to define. It's actually arbitrary how many colors we have in English. Not every language has the same equivalents. Like for example, there's no word for orange in Russian. Every language is. In fact, it wasn't until the Industrial Revolution, like westernized societies, started to talk about blue and green are often not separated into different colors. So, hues are basic color. From a hue, we can assign value to it, how light or dark the color is, basically how much light, white or black is in that color. So we can have a pink over here on the one side and a very, very dark red, almost to a black, over here on this side. And then saturation defines how bright the color is. So whether it's muted or more of the pure color. Okay. So hue, value, saturation. We use these specific terms because we need ways of talking about these, and we're going to talk about some different color systems. So they'll use hue, value, and saturation in those senses. Okay. So if we look at a color wheel, all right, you guys probably all remember a color wheel from elementary school in art class. You can look at these different things. We have primary colors and complementary colors. Which are our primary colors? We're talking about paint. Red, yellow, blue. All right, and then we have secondary colors that are made by mixing those, which are orange, green, and purple. Yep. So these, and then we have shades in between. Thinking about a color wheel can be pretty important, and so if we want to show, if we want to differentiate things, we should pick contrasting colors. So red and green. Now the more opposite you are, the more those colors are going to stand out. And in fact, those complementary colors, red and green, for example, they really vibrate against each other. So they don't tend to look, depending on what you want to do. If you really want them to stand out, you can do that. That tends to make your map very, very violent. So you may want to shift over slightly, like red and blue or red and yellow. if you have categories of things or are showing like a political map, then you want to show separate states. You might need 4 or 5 different colors around the color wheel, spaced out as much as you can to help show those apart. Like you probably have seen like political maps that have each of the states colored just kind of randomly, but so that no 2 things next to each other are the same color. You're going to want to pick a certain number around here, and usually 4 or 5 is adequate. It's hard to get a geometry where 5 things are going to be touching each other, so you don't usually need that many different colors to do that. Now, when you pick colors that are closer together, it tends to add harmony. It makes things a little easier to see, or they stand out less. They sort of blend together. So picking blues and greens or oranges and yellows can be useful. Although if they're too close in their value or their saturation, they can start to. It's really hard to tell those kinds of colors apart. All right, so let's look at some different contrasts. So here we have those point symbols again that are contrasting in color. Red, blue, and yellow are pretty much universally easy to tell apart because they're as spread out as you can with 3 colors on the color wheel. And in this case, we've also added differences in shape. So that's a lot of that provides a lot of contrast, and we're really trying to show off these different things so that you can identify them fairly quickly. You can start to see it's actually easy in this case too to look for groupings of things. So those blue dots are spread out pretty much all over. The yellow dots are a little bit more concentrated. The red dots also are not as common and so have a little bit more concentrating. You can start to see that fairly easily. Now if you use muted, so bigger areas, points, you can use some pretty, you tend to want to use some pretty strong contrasting colors, particularly with the background, so that they really stand out. But if you're making a choropleth map like this, if you're showing land use, if you're showing areas, you tend to want to use more muted colors, because the stronger the colors are, the harder it is to really look at. It starts to become just too much difference, and then it makes it more difficult to look at. All right. Now, often we're gonna probably prefer monochromatic color scales, sticking with a color and different values. So going from light to dark or dark to light, depending on which thing we want to emphasize. It tends to be better to use more light shades than dark shades because our eyes are better at seeing differences in light colors than they are in dark colors. So how you set up your ramp, you can change. ArcGIS has a lot of these built in, but you can adjust how dark you want to go from where to where, how many different categories you want to see. We're not on a map. It can be hard to get to really see a difference between more than 5 or 6 levels of the same color. And so you may have to think about other ways if you need more categories than that. It can be a little bit difficult. So let's look at what happens in a monochrome map. All right, so here we've made a map of percentage of the population over 65 by county for the U.S. And can you tell where there are 10% from where there's 20%? No, you really can't. So these values are way too similar. So you need to change the map. You need to basically increase the contrast so that you can start to actually separate this a little bit more. Maybe you have too many categories. You maybe don't need this many categories, or maybe you just need a slightly different color system. So if we look at this, we get a little bit more contrast. Now, can you pick out the difference on this map between 10% and 20%? Should be a little easier. All right. And so a couple shifts, it makes it they added some dark, which means the nice thing about that too is you start to see the ends a little bit better with that very little variation between the lowest value and the highest value. It's hard to pick out where's there really high percentages and where there are really low percentages. You can see that stands out much better, and that's probably something you're going to want to talk about. The middle is all kind of the same. But thinking about which places have a lot of older Americans versus a lot of younger Americans, it's kind of interesting. In fact, some of these places, look at this, some of these places, they're right next to each other, which is interesting. Must be something going on there. That's actually right there. That's Austin, and then north of Austin. So there are different ways of assigning colors on computers, and it helps to be a little bit familiar with them. We're not probably going to have to worry too much about the specifics, but how you pick these colors can actually make a difference, because if you want to try to keep the same color, it can actually matter. So sometimes you may have imagery, or you may have other things, and you want a specific color value, and if it gets off, it can make a difference. So switching between these systems, some of these systems can display colors that others can't. That can actually make kind of a difference. But to start with, we have RGB colors. So red, green, blue color system is what started off with TVs, old cathode ray tubes. You guys remember old TVs before everybody had flat panel TVs? Any of you guys have a regular TV when you were little? You don't remember? Some of you guys did. Maybe some of you still have them somewhere, like in the basement or an attic or something like that. But those had 3 different phosphors: a red, a blue, and a green, and you could make almost all the colors based upon those. So monitors still use this system. They don't have to anymore, but they still utilize that system. So you'll see that as a choice. And so, yeah, that's still pretty normal. In fact, I might be wrong, but I think camera sensors still use RGB sensors to collect those light data. All right. Now, a more typical thing, and what it defaults to in ArcGIS is using HSV, so hue, saturation, and value. And so this is often used in computer graphics. It's a little bit more convenient because you can have sliders for saturation, how much color is there, or value, how dark or light it is, and you can pretty easily find what color space you need to be in. When you're moving red, green, and blue, it's hard to make things dark and light. That's a separate thing from those systems. And then HSL, hue, saturation, and lightness, it's basically a different version of HSV. So there's not much difference, but you might see that written in HSL value. And then finally, there's CMYK. And this is a printing system. So color, if you've ever noticed on like the color printers, they'll say that like one of these toner colors is out: cyan, magenta, yellow, and black. So it's key black is for the K. Cyan is blue, if you were wondering what color is cyan. Magenta is red or pink, and yellow is yellow. It's sort of the standard one. But those 3 colors, like if you're mixing paints, you can mix a certain amount of them and make a particular color. And so this is pretty typical. If you're making a map to be printed, and you're worried about the colors, it's a good idea to work in this color system. Any of you guys have art? Any of you guys take like a graphic art class or something where you talk about this? Yes. But anyway, these are kind of things if you probably really won't need to worry about, but I want you to make aware of, because you'll get to. Oh, sorry, I didn't put this on here. In ArcGIS, you'll be able to select which of these systems you want to use for picking colors. And so that's HSL, hue, saturation, and lightness. There's a hue up there. You can switch from red to purple, and then how saturated, how much color there is, and how dark that color is, and even a transparency value, which you can do transparencies in ArcGIS, which helps you show so you can see through things. But they haven't yet figured out a way, and I wish I knew a way. The transparency changes the colors, and that bothers me. I wish there was a setting in ArcGIS. If there is one, I don't know about it. If anybody finds it, let me know. It drives me crazy. I want to make things transparent, but then it changes the color, and then your key is not the same color as it is, and it messes things up, and it drives me crazy. I don't know why they haven't fixed that, because it seems like something that should be fixable. But all right, so there are different ways of playing with these things. So here, these are both monochromatic maps, one color, but with different hue, saturation, and lightness. So we have more saturation and more and a darker value, or it's just darker, more saturation and more darkness in this right map over here, much more muted here. All right. There's reasons for both of these. You can pretty clearly pick everything out in this one, and so you may want these more muted colors. If you were including this graphics with like text or something like that, or if you were going to add some more symbols onto this map that you wanted to see, you just wanted to show. You really want to just point these things out and have them have as much contrast as you can. That's a good map for that too. All right. So monochromatic color schemes generally are preferred if you have one variable. You don't have to, but it kind of works, because you can contrast that then with a dichromatic color scale where you're working with two different colors. This is very useful when you have a middle value of something like 0. So where there's no difference or no change. This is good for change maps where something's increasing and decreasing. You can use one color to represent the decrease and one color to represent the increase. And that's what this map is showing. Population per square mile change, where the yellow values are a decrease in population, the purple values are an increase in population. And they picked contrasting colors, so yellow and purple, contrasting colors. That helps separate them as well, with a very light gray for the county boundaries, so that the boundaries are not overemphasized in this case. And you can pretty clearly see places that are having fewer people and places that are having more people move to. Everybody's going to the coast. Get out of the Midwest. It's been rough. All right. So, if you have a qualitative map where you're not illustrating numbers, you're just illustrating things, categories of stuff. All right. Just pick clear colors that your eye can easily go to. Now, what's important to keep in mind when you're doing this is that about 8% of men and about 0.4% of women have some level of color impairment. All right? So color blindness is probably not the preferred term. They just don't see colors the same way as other people do. In fact, there's probably a bit more variation in this than we normally talk about, but for some people, they really cannot differentiate certain groups of colors. And it's helpful to keep this in mind. It actually makes your maps better if you build them for people that have color vision impairment, because it typically means you're picking good contrasting colors. So I'm going to take you over to this website, colorbrewer2.org. Super fun website that I like to help pick color schemes. They have very nice ones. I'm going to switch over. I'm going to show you these here. Here's Color Brewer. All right. So this website lets you pick differences in single hues. It lets you pick multi-hues, things, ones that work well, that will not cause different kinds of that will be visible for anybody, no matter what kind of color impairment they might have. You can increase the number of classes, so you can start to see more variation in these different ones, even in single hues. They're all set up nicely, and if you look, let me switch to. You can pick either an RGB or CMYK, what the values would be, and you can type these into ArcGIS and actually set it so that they're right, essentially. You can pick then diverging color schemes, which is a place where it can get into trouble, particularly if you're picking colors that are too similar, or that somebody that has color impairment would have trouble differentiating. But these are set up to sort of help with that. And then there's different kinds of of qualitative maps, so where you have just different colors. So all of these values should be differentiatable if you are color impaired. Maybe that's too many. Let's go down to 4. See some different sets of things, and they give you some ones that have a lot of saturation, some with less saturation, some darker ones, some lighter ones, all of which is this. Now you can check and make sure that these are colorblind safe. Most of these would work okay, but this little checkbox right here ensures, and in this case there's only one of the if I turn this off, not so many. Or printer friendly, that's another set of choices. Some of these colors won't work so well, but these qualitative ones, mostly you'd want to work with these anyway, and most of these are all ready to go. Make sure you could make sure you get print friendly ones or photocopy safe ones, so that a photocopier can actually differentiate all those different colors. Depending on what you're doing, that can be super helpful. So there are these are here, and then these values can be entered in. You can look at it if you want to see what it looks like with terrain or different transparency levels, all of which are different possibilities. If you want your map, so they're all there. Let you play around with it. So anyway, I find this to be a super helpful website for picking out colors. So colorbrewer2.org. All right, so a couple of other display tips for features. All right, in general, what you want to select are simple, solid shapes for point values. The more complicated, and you can use lots of fun, fancy symbols. You can load JPEGs and do lots of different kinds of things in ArcGIS, but you're going to have to be careful then to show what you need to. Now, here we have a zoom in on that same map. It shows these different food facilities. In this case, they're not colored differently. You can still pick them out, but they tend to blend together a little bit more because they're all black. There's not a difference in color in this particular case. But since the shapes are distinct, that can be helpful. So if you start getting those pluses and stars, and there's other shapes you can pick in ArcGIS, they do tend, at this scale, would probably be fine. You could tell them apart, but the smaller the scale map, the more symbols there are, the harder it can get to start telling these things apart. All right. This is a large scale map, right? We're pretty zoomed in. We're zoomed in on blocks, and we're showing different types of crimes. And there may be some very specific kinds of symbols that in an industry people are going to recognize that you could use. You can use on large scale maps more detailed symbols. It's usually less of a problem than on a small scale map where you're showing huge areas and they have lots and lots of dots. Don't pick these for showing like US crimes or something like that. You're not going to be able to tell what they are. All right. And so here, even in this case, we only have one symbol. This is a school symbol. This is at a smaller scale, so Pittsburgh, the whole city of Pittsburgh, not just blocks. And it's just way too busy. It's a pretty complicated symbol. There's a lot of them here, and it's kind of just messy. They overlap so much that you start to get weird shapes in different places. This doesn't work so well. So in this case, you want a much simpler symbol to illustrate where the schools are located. All right. Here we have a quantitative map, and you want to make sure there's enough differentiation between the point sizes to illustrate what you're trying to show. So here we're showing persons below poverty level receiving food stamps. The more number of them, the bigger the symbol is in each of these areas. All right. So how you select your labels and your fonts is also important. These labels tend to be pretty easy to read, right? So why is that? Can you pick out any characteristics that make these fonts easy to read?
The halos around the letters.
Yep, so there's halos around the letters, so there's a white halo around the letters, and that helps separate them. What else?
They're bolded.
They're bolded, so nice, thick, heavy lines.
They're black, otherwise if they were white.
Yeah, they're black, and so sometimes white Sometimes white letters will stand out more than black letters, just depending on your background. But yes, in this case, the black helps a lot.
They're small enough so like the ones that are close together aren't too tight together.
Right. Yeah. So there's good spacing between them. They're fitting on here very well. Anything else? You guys are coming up with all good ones. What about the type of font?
Simple font.
It's a simple font, yes. It's what we call a sans serif font. So serifs are the little extra lines that are on fonts, and when we're labeling a map like this, a serif font is okay if it's the title or something like that, but most things you want to label this way so that the letters don't run together and look more clear. Unless you're really trying to go for a very fancy, old-fashioned looking map, most of the cases you probably don't necessarily want to deal with that. All right, and so here's just another example of a different kind of map. This is a heat map, and so what you generally want to think about is what Esri calls smart mapping. So thinking about different ways that we can transform data into graphics, and we want to make it a map that's clear, that people can look at without too much help, understand what's going on in the map. All right. So I'm going to show a couple of examples. There's a couple of links in here that you can take a look at. One is just on all the information about symbolization. But there's also actually I couldn't get these links. Should work, but they weren't. But we can check that out. I want to show you one other thing quickly, which I think is pretty amazing. So this book is called Thematic Mapping. Let's go back here. So I have an ebook. I only have an ebook version of this. It's too bad. I should really just buy it, but the physical copy, so you can show this. There's 101. Is it going to load? Hello. All right, let's look at. No. Come on. I wonder if it's blocked. All right. I'm going to stop recording.